Generally, invasive species are damaging to U.S. fisheries because they represent a wide range of both ecological and economic downsides, which we see once they're introduced, ranging from the fact that they cause physical ecosystem damage and degradation. They serve as a vector for disease and parasites, which organisms within the ecosystem might otherwise be unintroduced to and might not have any natural defenses towards. And they can displace native species through a competition between them. In addition, just to get at the economic downsides, just within North America for marine invasive species, the damages within 2018 were estimated to be $166 billion US, and within North America, of all the studied groups, was the largest, including some like Europe and Africa. However, controlling these native species is difficult once they've been introduced because all of the proposed and tried solutions, all of their various downsides. Chemical controls tend to cause damage to other species which aren't being targeted, and they can run off into the other ecosystems adjacent. Manual removal is really expensive, often impractical, and difficult depending on the species that you're targeting. For example, earthworms from Europe are invasive to a lot of the US, very, very difficult to try to remove every earthworm, as you might imagine manually. Biological controls are often quite difficult because you run the risk of that species in turn becoming invasive in the environment. And this has been seen with some parasitic wasps targeting stink bugs. As an example, biological control, which are thankfully not invasive yet, but you have to keep in mind those risks. Mechanical controls, such as the electric dams targeting carp, or electric barriers targeting carp, are often geographically limited and very expensive. And lastly, cultural change, with trying to get everyone to target, such as anglers, to target a species that's invasive and remove it, can be extremely difficult to do, especially because those sort of outreach programs tend to be independent of the research that's being done. As a result, functional eradication utilizing fisheries may be the next best thing, as was mentioned by Green. And this is, instead of full eradication, reducing population levels to a point at which the detrimental effects to the environment are low enough that they are closer to negligible. Goals of this study are to analyze timelines after the initial native invasion for aquatic invasive finfish within the US, determine whether there's potential preferences for domestic or foreign consumption, because regarding invasive species, market studies have shown that there are preferences against native species because anglers and people consuming them view them as trash fish, particularly with carp, because they cause so many issues. And to determine potential preference for export back to countries where the species is native, off the assumption that foreign consumption will be favored and that countries where the species are native will have a preference for the fish over countries where it is not native. The data sourced for this study was from several different organizations, where FAO, the Food and Agriculture Organization, provided the raw catch data. CEPI, which is a French organization, used the Baki data set, which is a bilateral trade data among several, pretty much every country. And then Arctis, which is what my advisor is working on, utilizes both of those two data sets to make international trade manageable to look at and study. And then FishBase was used for general species information. Regarding the 79 total finfish species known as invasive by FishBase, or listed as invasive by FishBase, 72 of them had zero catch data present or consumption data present at all, and only seven of them had any consumption data present. And of those species, those three that weren't carp were extremely negligible, with grass carp being the smallest consumption data of any of the carp species, being double that of goldfish, and then snakeheads being next to nothing at 0.07 tons. And this is mean annual catch data between the start of the data set at within the 1990s and about 2018. Regarding the carp species, as they have been established to be the best case study here because they have the highest catch data and they are economically important within their home ranges, we can see that based on general catch data within tons by year, that common and bighead carp have decreased and grass and silver carp consumption increased. In addition, silver and bighead carp values started only in 2010, and this is potentially due because the CEPI data set uses something called HS codes, which are harmonized codes, which are at a product level and not a species level. So this is because this can lead to certain things being classified as genus or just by crab, because with your invertebrates it can be very difficult to classify all of them at species level. In addition, I answered tried to answer most of my questions anyways with specialized consumption graphs generated in R, utilizing the Explore Arctis package, and in addition with some data cleaning that I had to do from FishBase. And here is a consumption graph showing initial date of invasion for these carp species denoted by a red dotted line around the 1970s in relation to the catch data over time. And then we can see that initial invasion happened in the 1970s or so. Consumption values started extremely high for bighead and common carp, and consumption values started extremely low for grass and silver carp, which, given they've all been invasive since the 1970s, we would assume that all these values would start high, because we would hope that they would have established fisheries, but they don't. Domestic as opposed to foreign consumption, they were grouped into bins by US consumption, and then all other countries exported to for consumption values. There's a lack of discernible preference for export, as we see equally high, if not much higher, consumption values within the US, and the proportional exports by year remained relatively consistent between species, outside of an extremely strange spike in 2003 with the common carp. And then for the nativity of countries exported to, the assumption here was that most of them would be transported back to countries where they are native to. However, this was not the case, as we saw about similar proportions for the bighead grass and silver carp for countries that are shipped back to, the exception of common carp, which saw an extreme bias for its introduced countries. And this is potentially due to the fact that common carp consumption values were drastically higher than the others, leading to discrepancies in the data because the markets in the other countries could have already been saturated and they could have been looking elsewhere. Interpretation of results. We see that there is a market for support for fisheries within the US and outside the US for commercially viable invasives. So that provides some hope that we can potentially work towards functional extermination through financial incentive towards anglers. However, regarding timeline analysis between date of invasion and market establishment is tenuous because the data set does not extend all the way back to the initial date of invasion. There's no apparent bias towards foreign export as predicted, and there's no apparent bias towards native country export as predicted. Regarding future research potential, investigating why export values for bighead carp only started in 2010 despite high initial consumption, despite the fact that they were presumably being caught and consumed prior to that point. It would be worth looking at HS code changes and seeing if that's why there are differences there. And an analysis of species invasive to countries where the data set covers the initial set of date of invasion. So looking at a different country where the species is invasive within the data set could be useful for seeing if there's a approximate amount of time before the market begins to develop and people begin to consume new species. In addition, while we did see no preference towards foreign consumption, no preference towards native consumption for these fish, when comparing the data towards markets similar native finfish species, trends may emerge that indicate preference relative. Ready for questions?
I'm curious if you came across any examples where like a fish was introduced because people like to eat it and then became invasive from there.
Several. So for carp, that's one of them because there's a lot of escapes of carp, but there are several species within the data set for introduced species to the US that I would expect to show up but did not show up. The biggest group of which being tilapia, because regarding global finfish or freshwater finfish aquaculture, carp make up about 50% of it, according to FAO cache data, and tilapia make up the second most at 10%. So while they are invasive to the US, them not showing up in capture data, because this is all specifically wild capture data, no aquaculture. is very strange that we don't see tilapia present at all. So it's odd that carp are the exception where that would happen, but other species aren't.
Thank you for your time.
Hi, Bailey. Yeah, thank you. Sorry, I was a little late, but I think, yeah, it's, I think, really cool kind of sort of like this time series you're able to pull out, like, sort of the pictures you're able to get from this data. I'm curious, because like, I work with artist data too. Like, what's kind of like a big takeaway that you've learned working with this data, and like, what do you think that plays into understanding how we are consuming our quality foods?
So in terms of this data set specifically, what it did that FAO and CEPI did not do is I did have to write my own scripts for several of the things, but it was really easy to work with once I had that done and I could get all of the data that I wanted to answer these questions, as opposed to having to do some really awkward amalgamation of the data. In addition, the artist data I had to do this in R because global trade data is so large that I can't do it in Excel without crashing my Excel. So it was extremely useful to be able to filter all of these things to these tiny little species which may not be used for consumption, or the second main reason for introduction, which is aquaria. So it was really nice to be able to get species level data for any country that I wanted, for any category that I wanted, like aquaculture, wild caught, that sort of thing.